Welcome to everyone here in Paris as well anywhere in the world for the second roundtable on our live studio here at the World Poultry Congress Congress Center in Paris. The topic of today is liquid additives in the feed mill with a very simple motto, to be simple. And traditionally in feed mills, we are managing huge quantities of dry materials, grains, flours, and so on. We grind that and so on, but we also incorporate liquids, either as ingredients or as micro-ingredients or as additive. And this will be the topic of this second roundtable. We have the pleasure to have around the table three experts. Tom Hughes from Moy Park, Innovation Manager and Nutrition at Moy Park in UK, representative of the end user, I would say the guys that will challenge the two other speakers. Joan Brusosa from Mangra in Spain. He's involved in the sales management and international sales manager of Mangra. And Mangra is a liquid equipment supplier. And Marc Perel, Global Solution Application Manager at Adisseo. Welcome to all of you, and I think we are going to have an interesting debate on how to do simple with quite a crazy things. And you see the image on the screen, putting water in something which is dry, it's basically it's quite a nightmare. Our roundtable will be structured in three main parts. We will make the basics of liquids, why we use liquids, how much liquids, and so on. The practical applications, the technicalities of the application, and after, how do you see the future of the liquid utilization in the feed mills? So I remind all participants that you can ask questions, whatever you want, whenever you want, and we will ask the question to the speakers. And if we don't have enough time to answer to all the questions, we will get the response afterwards. So now let's begin with you, Tom. Can you give us some elements on your poultry feed production and how you deal with liquids in your organization?
Okay. Thank you, Pierre-Andre, and it's a pleasure to be here. Thank you very much for the invitation. Yes, you mentioned that the theme should be to talk about simplicity. Unfortunately, once I start to talk, the simplicity goes out the window. But the company, just to give you some basics, we started off actually as a layer business back in 75 years ago in Northern Ireland. But very quickly the opportunity was spotted that there was a big developing meat market, and the company got into both turkey production and also broiler production. It grew from being a small regional producer of both broiler meats to now becoming very national, so covering both Northern Ireland and also the Great Britain mainland. Today we grow upwards of 5.5 million birds per week. It's all broilers, and we control all of the feed formulations for about 95% of that. The business itself is broiler meat. We produce our own parents, and we also grow and produce grandparents as well. So it's quite an integrated broiler business. We own all of our own hatcheries. We own half of the feed mills, and we work with our feed partners on the other half. And then we obviously deal then directly with the end user, the retail customer, the fast food service, and the ready to cook, ready to eat type business.
So directly to have the hands in the production. So you are involved in the feed manufacturing as well as in the poultry production. So I think
absolutely, and I mean it's seen as key for our company. We need to be very close to our feed formulations, the valuations of various raw materials, and also the production of the feed, so that we understand the costs. They are very significant, as you would understand.
And globally, what type of liquid ingredients or additives and so on you are using today?
It varies by feed mill, but we do have a plan. We do have a concept of where we want to be across all feed mills. We want to maximise the use of liquid materials where we can. So today we use obviously liquid oils, but we also use liquid enzymes. They're all sprayed on post-pelleting, organic acids as well, and also some liquid amino acid. But it's not in all plants equally, but we're developing towards that.
Okay, thank you. Mark, regarding the micro-ingredients, the liquid micro-ingredients, can you develop a little bit more on how we can use that? What are their characteristics, their constraints and benefits? Because obviously it's interesting at the end application. So,
well, actually, I think it's good to separate macro ingredients and micro ingredients, as said by Tom. We cannot put them in the same basket. What is my definition of micro ingredients? They are raw materials such like oils, fats, even molasses, glycerol, and so on. With, let's say, I would say a high level of inclusion, let's say basically from 5 to up to 50 kg per ton. On the other hand, we can speak, and we will speak today about the liquid additives application. And here we can say that the range of application goes from 100 gram per ton up to 5 kg per ton. What makes the difference apart from this range of inclusion? It's mainly the biological activity and obviously the cost. These translate in a difference in terms of requested accuracy. That's the main difference. What we can find in terms of micro liquids in a film mill? First, at the reception, we may apply, or the customer may apply, acidifiers and antioxidant. Then comes the main place for liquid addition, which is the main mixer. In the main mixer, apart from the raw material, you can find amino acids and analogs, such like methionine, lysine, and also choline chloride. You can even find these acidifiers and antioxidant pigments also. And I would say in some cases, since the enzymes are thermostable, they can be added prior to pelleting or even on mash, on crude mash. It makes sense. And lastly, as mentioned by Tom also, some additives can be added in post-pelleting, such like liquid enzymes and even palatants. Now, if we speak about the characteristics and constraints, first of all, it's the composition. Is it a single molecule, single phase, or a mix or a dilution? And then we must focus on the physical and chemical characteristics, such like pH, pK, and corrosiveness, density, viscosity, and the viscosity regarding to the temperature, the water content, solubility, the potential interactions that may happen between some liquids, the sensitivity to microbiological contamination, such like for enzymes, and so on, and most of all, the range of inclusion. And to come back to your motto, you mentioned Pierre-André. I think the main benefit, I think we will develop later on, but the main benefit is the ease of use. And so that's beyond the cost efficiency in formulation. But I would say the ease of use is the best or the main benefit. It offers a better flexibility in the plant design. There is a possible high distance between the storage and the addition point. You also have an extensive automation, and when you have liquids, it frees some microbeans for powder additives. So this is, let's say, to make it simple, the main benefit is the ease of use for liquids.
Ease of use, so you maintain the simple way. So Johan, the first question when we talk about liquid application is the equipment. So what are the first questions the end user ask you when they want to implement a liquid utilization in their feed mill?
Yes. Okay. I think Mark already said almost everything, but I would say that it's my questions are the W question. So which liquid, where do you want to dose it, when do you want to dose it, the quantities you want to dose. So you need to know very well the liquid characteristics. So as he said, the pH, corrosivity, viscosity, density, because all those things affects in the way to flow this liquid. You need to know where do you want to dose it, the mixer, post-pelleting, the quantities. All this determines the line you will need to do, pumps, flow meters, valves, everything, nozzles, if you need it.
So today, when you start from scratch, I would say that's a relevant questions. But very often today, people are already using some liquids. So do you have questions about how do I further incorporate now another one in my application system? Do I need to revise completely the system, change and so on?
Well, it depends. If it's an existing liquid, most of the information is already available. In case of a new liquid, then you need to know it. Okay. There are also another number of questions. It's a liquid that needs to be warm up. Yes, not. If you need to warm up, how to do it? Do you have an electrical tracing, or do you have steam? Do you have hot water? All those things, it's necessary to know the distance and where do they keep it, where they do to store the liquid in a tank, in IBC, in drums.
Today, when we talk about liquid, for instance, and you talk about new plant, is that something you address immediately at the beginning? You are often challenged by end user to say, okay, I'm going to implement a new line, a new plant, and so on. Are you operating straight from the beginning of the thinking of the design of the plant?
Yes, sometimes yes. You mean that the plant from scratch? Okay. Yeah. Well, usually the engineers who designed the plant already used to dedicate a room for the tanks, a room for the pumps, etc. But design of the lines inside, we do it. Yes.
Okay. So definitely you jump immediately on the application, on the practicalities of using liquids. And I want to ask a question. Yesterday we had an opening conference on water. So we talk about water loss, water activity and so on. One big question is we put liquids. What is the constraints regarding the dry matter or the liquid content of the feed at the end? Can we put more liquid in the feed, Mark?
Well, if we leave aside the specific subject of some additives such like emulsifiers, let's say surfactant or organic acids, which aims at either lower the water activity or let's say control the microbiological activity which can come with high moisture or high water activity. If we leave this aside, I would say that this topic of feed moisture is not a topic, is not relevant. Why? First of all, let's not confuse liquids and water. In some additives you have water, in some you don't have. The main water suppliers in the formula are not the liquids. They are the dry ingredients. This is what brings more, like soybean meal, cereals, and so on. And if you compare two formulas, one with dry micro ingredients and liquid ones, the difference in terms of moisture will be from 0.1 to 0.2 points maximum, which is negligible. By the way, this criteria is well known by the formulator, is considered by the formulator, and if you consider the additives, it is known and very stable. I mean, do you know the moisture of this truck of wheat? Okay, you have a range, you have something in the matrix, but it's not so accurate. You may have variation of a half point, 1 point. For liquid additives, it's very stable and known. And I also ask you, I like this, it's a joke, you may know this joke of what is more heavy, 1 kg of feather or 1 kg of lead? I ask you the same question, what brings more water? 1 kg of wheat at 12% moisture or 1 kg of liquid methionine at 12% moisture? So for me, it's not a topic.
It's a good example to say that we often talk about water, but in fact the liquid incorporation does not contribute too much to the water content.
It's a bit misleading.
But it's just to appeal the contradiction, you know.
Yeah, of course.
And so, by the way, do not hesitate to ask questions from the audience. It's we are totally open to receive questions. So I think starting when you start to use liquid, Tom, what are the main questions rising, in your heads when you say, okay, I may choose a liquid for the same type of product and so on. What are your motivation to move to liquid compared to stay on the powder? Or?
Well, again, going back to keeping it simple, first of all, technically it must have a sound argument. And we need to, I suppose, first of all, believe that there's something worth looking at. The product, to move from what we already know, a dry product version, to maybe something in wet, we need to know that it's at least as good or better than the dry version, and also at the same cost or better. So there needs to be some particular advantages for us to want to change. We do have a process that we would follow to evaluate new raw materials, all new raw materials, and we would include liquids in that, whether they be lots of moisture, liquid water or not. And we will run it through a trial plant, a trial facility that we have where we can test to see how technically it affects the performance of the birds. We'll also watch the performance of it in the feed mill, of course, to see that the pelleting characteristics are not changed unduly. And then we will start to take that information, that confidence that we've gained from our small scale studies, and we'll start to roll it into commercial farms, regional groups of farms, and then eventually our full estate. So there is a very controlled process to monitor and measure at all steps.
Interesting. So, in fact, you really evaluate the potential efficacy of the product and so on. So I think as soon as you are confirmed about it's a good product, gives good efficacy and so on, what are the next questions? You are using, for instance, already a liquid, so you introduce a new liquid. So what about the compatibility? What about the mixing possibilities of the liquid prior to the incorporation? Or all that question arrive also?
And obviously that's very important because it can affect the infrastructure in the mill, and we may have to make some adaptations and talk to suppliers such as Mangra, and they are very professional in that area, and we take their advice. So depending on where the liquid is added, we may or may not need to introduce new equipment to accommodate that. We need to know, as has already been said, bulk density, the sprayability. Do we need to add more moisture to it on site to allow it to be added effectively, efficiently, and of course accurately all of the time. So we take those things into account for sure.
And John, just to follow what Tom said about including a new additives as a liquid or a new ingredient as liquids, what are the questions often you say, okay, you have first to look at all these points before to go further and to implement the system?
Well, I think, again, the same I told you before. So you need to consider which liquid, where do you want to dose it, the quantities you need to dose it. It's not the same, the macro liquids to the mixer than micro liquids, enzymes, aromas, some amino acids to post-pelleting, okay? The process is quite different. But you need to know very well the characteristics of the liquid, quantities to be dosed, when, accuracy required. All these things determines the choice of the pumps, flow meters, valves, and everything you need for control. Okay.
You an opportunity to revisit the design of the line, design of the plant. Yes. I suppose. Yeah. Yes. So we have some question from the audience.
Yes, thank you, Pierre-André. I'm with Rob. I would like to ask a few questions.
So this is
Hi, Rob.
Hey there, Pierre-André. So a couple of questions actually.
Hey, close.
The first question I have is, with the accuracy of the dosing equipment, what sort of accuracy can we expect for liquids, and does that depend on the type of liquid that you're using and or the equipment that you're using?
That's a good question. So I think you are all involved in that because it's really at the end the practical consequence of putting liquid. So maybe Mark, you start with the...
I can start with the objectives. So thank you, Rob, for this relevant question. So accuracy, I hear two things. Accuracy starts with dosing. Either with a scale, either with a flow meter. First of all, I need to take the right part within some tolerances. Let's assume I need 5 kg. The formulator, more generally, will fix some tolerances. It's 5 kg plus minus what he wants. First of all is dosing. So to answer your question, and I will let Johan comment further, but I would say with most of flow meters you can have an accuracy below 0.5% by experience. Then when some people say accuracy, they also mean the spraying accuracy, meaning, okay, I have the right quantity in my hand, how to spray it the proper way in order to achieve homogeneity. So this is how the liquid will meet the solid, will meet the mash inside the mixer. So again, it's a matter of good practices, but maybe I will let Johan develop this point. A good big question.
Yes, as you said, flow meters. Nowadays we have a very accurate flow meters, Coriolis mass flow meters or electromagnetic flow meters with a very good accuracies. Accuracy of the flow meter is part of the business only. You need also accuracy in the valves and etc. So I would say that in terms of dosing, accuracy could be easily achieved. Okay, homogeneity, that's a different question. So this it's something which not depends on the equipment. Sometimes depends of the mixing equipment. So it's type of mixer, if it's a big mixer, or in a case in post pelletings, does the post pelleting have a good blending post pelleting system? Because the homogeneity, the deal of the homogeneity is there. Okay.
When we talk about homogeneity, maybe the nature of the ingredients, I would say corn, wheat, byproducts and so on, will influence also the incorporation of the liquid and the homogeneity.
It may well have an effect, and we do take that as a very serious subject. I didn't mention it earlier, but we do rely on our analytics quite a lot to prove that the homogeneity and also the delivery of the product is accurate. I suppose in the mixer, our own targets for mixer homogeneity would be less than 5%, and we are not testing that every week. It tends to be pretty consistent, but they are our targets. For spray-on enzymes, we're because the volumes are so much smaller, it can be a bit tricky, so we do a lot more regular analysis, and we depend on our suppliers for that. Typically there is also a background supplementary amount of enzymes included, which helps to cover up, I suppose you could say, any inaccuracies, whether it be speed of flow in through the spray-on area or not. So we're always achieving a minimum enzyme activity. That's our target. But we can see a lot more variation in the enzyme accuracy than we do on the mixer accuracy.
And the level of accuracy you are targeting, you mentioned 5%, but it's for all product or
5% through the mixer. For enzyme, we look for minimum activity, but we can also sometimes see plus 20, plus 30% activity in the actual product itself. So and variations around that. So, I mean, that might mean it's about 10-15% variation in accuracy.
So you challenge your analytical lab to give the most accurate value, whatever the type of feed.
And it's essential that we have that backup from suppliers.
Mark, you want to complement?
I have another question coming from
wait a minute. Mark wanted to complement.
Just to comment what Tom just said, you mentioned that you have a higher tolerance for the coefficient of variation for liquid enzymes. I guess this is not for the application itself, but mainly we know that for enzymes the analysis is less accurate. So the variability that we measure at the end of the day is the sum of the variability of the process and sampling plus the lab analysis, and maybe this is why we have this difference in terms of tolerance.
And actually with spray-on enzymes post pelleting, actually the only real metric is how accurate it is in front of the bird. So if we have a pellet that actually breaks down and doesn't withstand the attrition that it can have as it leaves the plant or moves in the transport and the blowing system on the farm and then the feed distribution on the farm, we've lost. So it doesn't matter how accurate we are in the mill. If it separates before it gets to the bird, then we get concentrations in the dust and maybe not in the pellet, and that's a problem.
So it's a big challenge for the supplier. Maybe another question. I
can ask questions all day long.
Yeah. We know that, Rob. No problem.
So, question for Mark. So, you mentioned that you can add 100 grams to 5 kilos per metric ton, but really, what's the maximum total liquid that you can add to the mixer before you start seeing issues with mixability and feed manufacturing on a grand scale? Either as a mash or pelleted feed.
Actually, this mainly depends on the characteristics of the solid part. I would say this ability to absorb liquid. Let's take an example. We have one customer in China. They decided to make a dilution of liquid methionine on I cannot reveal you the secret of this customer, but they use a carrier which has a very high level of absorption, and they make a mix of 50% solid, 50% liquid methionine, which is extremely high. So this totally depends on the carrier, on the solid part, but if you go too far, you will have problems of flowability, caking, and things like that. So basically, to try to answer your question, if you include the liquid raw material, basically, roughly you can reach 5%, up to 5-6% in the mixer, and you have the flexibility to add oils also and fats in post-pelleting, which gives you more flexibility. You can put from 0.5 up to 5-6% depending on the type of fat at the post-pelleting. So basically, I would say 4-5-6% into the mixer, and depending on the type of feed, up to 5-6% of fat at PPLA.
Do you see any issues with those high inclusion rates and the interaction between different liquids? I know it depends on acid versus base versus fat versus hydrophilic.
Actually, we also studied the potential interactions mainly with our core product, which is liquid methionine. Let's say basically, first of all, we should say that we advise not to mix the liquids before their application, but sometimes you have to. For instance, on some mixer you have only 2 manifolds, so if you have more than 2 liquids, you need to mix them in the manifold. Basically, there is no negative effect, except when you mix lysine, which is a basis, and methionine, which is an acid. You have an exothermic reaction, but this reaction does not affect the molecules, so it's not desirable, but it's not a blocking point, I would say. So interactions are not problematic actually.
So when the equipments are, I would say, arranged in the feed mill and so on, what are the real benefits? You mentioned that if you have an opportunity, I'm using liquid, but do you evaluate a return on investment of using liquid instead of powder, for instance?
Well, there's, I suppose in the current climate, there's a number of things that we keep in mind when we're looking at something like a new liquid. I suppose we want to make sure that we have exposure to the maximum amount of the production base of certain materials. For example, enzymes, we'd like to be able to use dry and liquid in those cases. So that's actually a strategic decision where we want to be able to copper fasten or insulate us against supply chain disruptions. But then in terms of return on investment, within an integrator, we're competing for CapEx. So it needs to be a good solution for us from a return on investment point of view as well. And typically, unless it's for something like the liquid application, unless it's 2-3 years or less, it's difficult actually for the company to justify without some other major strategic reason to invest in the feed mill, because they can get a quicker return on investment if they invest in the slaughter plant or the processing plant. So that's a competitive thing.
When you think about return on investment, what are the type of parameters you evaluate? The kilowatt hours or the energy consumption, the storage, the change in the storage system, and so on?
Yeah.
How do you individualize, I would say, the different part of the savings?
So I suppose the basic return on investment is about the cost price and what it can return, and by formulation, yes. But there will be advantages that are maybe not fully monetized, such as the storage that was talked about earlier, less storage required on site if we use liquid. So it frees up some dry storage. There's less handling, so less labour involved as well, possibly less waste as well. So there are other advantages there that we maybe don't fully calculate into the equation.
Maybe you want to add some elements, Mark, on that.
Yeah, actually, I'm not so surprised by Tom's answer, because actually what is, let's say, easy and the first lever to evaluate this return on investment is the cost difference given by the formulation. That's obviously the first criteria that our customers look at. And indeed, as you just mentioned, first of all, liquid systems are closed and fully automated. This lowers the exposure of the worker to the product, less or no bag handling. This is also savings. Let's assume a plant producing 10,000 tons of feed per month. It means basically 1 ton of powder methionine plus 1 ton of organic acid plus each day. So how many pallets per day at the end of the day? And I would like to propose a KPI I like, but which is not so used in the feed mills, is the percentage of ingredients that workers need to pour at the end tip every day. In the formula, okay, I will produce...
Saving labels, saving...
Yes, today I have, I don't know, 5% of my ingredients that people need to pour at the end tip. Maybe I can play on that to try to lower this KPI, this proportion. And in these hard times of manpower, let's say shortage, difficulties to find manpower, I think it's a relevant KPI. And as mentioned by Tom, less handling time. If you compare bags versus IBC or even bulk, there is no dust emission, meaning less risk of exposure, dust emission, better cleanliness of the plant. And if I make a simple calculation, I could measure in a plant that handling 1 ton of bags leads to using 1 person for 56 minutes. If you do the equivalent with an IBC for the same quantity, let's say, it takes only 11 minutes. So if you still consider 10,000 tons per month of feed at 2 kg per tons, this leads to a saving, to an economy of more than 1 man for 1 month, 180 hours per year, which is significant. So it's in terms of savings, it might be included in the ROI calculation.
You challenge Johan on these parameters, because I'm sure that end users must ask to the supplier what are the efficiency, where I could save even on the liquid application compared to another liquid application. What are your the potential benefit you are going to bring to me? Quite challenging.
Do you mean comparing the liquid dosing, comparing with the powder dosing?
The first aspect is obviously liquid compared to powder, but after, end users are also using more liquids. So if you use a new liquid and so on, you challenge the liquid supplier to say, okay, how are you better? What is are you involved in the reduction of the time, reduction of the energy consumption and so on? Are you pushing on that too, on your side in Mangra?
Well, I would say that not only Mangra, the way of the liquid dosing applications nowadays is very efficient everywhere. Okay, probably as long as you consider direct dosing lines. Personally, I don't like to use the scales. Scales is, in my opinion, they are to mix all the liquids and they dose all of them together. This is you always have contamination. Okay, it's a little bit more dirty. But if you use direct dosing lines through the manifold, okay, in the manifold you can mix 2 or 3 different liquids which not compete against them. This is a very clean and effective way of dosing. So you have no losses here. Everything you got it, you dose. No losses.
So on the practical applications, you are dealing correctly and you are helping the end users to implement the system. You accompany the guys for control and so on. You have I would say a maintenance program also, because when we talk about simple, people want to have robust materials. So today you have a maintenance strategy.
Well, yes, there is not too much maintenance in liquid dosing lines. You have only the pumps, flow meters and valve. Most of the things are very well known for the maintenance people. Probably the only one is the pump. Pump has a period of life, but maintenance people know this very well. For the flow meters, most of the flow meters we use and are common today are with no pressure loss. So and you can check them very easy just with a test. From time to time you can test the quantity and check that your flow meter is working properly.
And for all of you, did you find difficult to educate people to use liquid? Do you have regular training on using liquid? Because we talked yesterday about education training. I think it's important. So on the liquid, it's very easy. So the worker at the plants are quite confident of using liquids.
Yes, I suppose we're fortunate as a company. I suppose big for ourselves that in our feed mills we tend to have a more stable workforce than we would in the slaughter plants. So thankfully, when people are educated and shown what they need to watch out for, it's generally quite straightforward. The one danger I would see with the liquids is because it is so trouble-free at times that people may sometimes forget to watch and to monitor and to measure. So they need to get into a routine that even though it's not a problem, to keep an eye on it is very important.
Routine maintenance to be sure that there is no problem. Maybe Mark, you are quite often involved in the training of people too.
Well, actually, the trainings are part of the, let's say, different services that we offer to our customers. Actually, we want two things with our customers. First of all, we want them to use safely, simply our products with an adequate addition in order to get the expected performance. If not, they won't be happy and they will leave us. And we want it to be seamless for them. So we want them we want serenity. We want to bring serenity to our customers. And as you mentioned, Pierre-André, trainings, product stewardship, hotline also about product and product application are the basic part of our mission and support. So indeed, we train the customer people for maintenance also. As mentioned by Johan, there are not so many maintenance operations, but I would say mainly controls. Yeah. It is important, but as for the rest, to control your process.
Okay, thank you, Mark.
Thank you, Mark. We have a question for you coming from the audience. So, given the differences in handling and properties of DLM and AT88, which has more shrink at the feed mill?
Okay, so maybe we can explain. DLM stands for DL methionine, so powder methionine, and AT88 stands for liquid methionine. So shrinkage. Actually, we have no data on this, so I will not invent some datas. In terms of quantities of losses, I understand this in terms of losses. There is no reason to have more or less losses if we compare these two additives. I see other difference. It's not a question, but I see an important question if we come back to the ROI calculation. It's in terms of electrical consumption. At the feed mill, we could make some tests in Tecaliment in France, the French Technical Center, and we could demonstrate that in some cases, in some diets, we could save up to 13% electricity at the pellet mill, which is significant, and that was confirmed by some of our customers. So you see here the gain is not in terms of shrinkage difference, but more in terms of electrical consumption, which is also, I think, a big topic for feed manufacturers nowadays.
The conditions of cost of energy, I think it's quite an opportunity to make some savings.
Yeah.
Thanks, Mark. Any other questions, Laura? Any other question?
Yes, Pierre-André, I have another question about the differences about the environmental impact between powder and liquid.
Good question. Regarding the sustainability, aspects and so on, what is the difference on the impact on the environment from liquid and powder? Who wants to tackle this quite tricky question?
Sounds like a great question for Mark.
Okay, so I take it for me. So I already spoke about the dust emission, which is part of this environmental concern. Beyond that, I think we should also consider the impact of packaging. So if I compare the two solutions, if we compare the usage of bags for powder, or big bags even, and if we compare that to the usage of IBCs, of containers for liquid, I would say that you don't need any disposal for the IBCs, which can be freely recycled, which is not the case, unfortunately, for paper or plastic bags. That would be, I would say, the main difference I can see, more for the packaging issue.
Okay. Any further comment on that, on the environment impact of choosing liquid or powder?
I suppose we haven't really evaluated it completely, but I'm aware there is a difference, obviously, in the packaging for sure, and potentially some benefits as well in the feed mill through adding some liquids. But we wouldn't want that to be taken into account in the cost of the product.
That is important. Yeah. So now let's maybe another question.
Is there any consequences on the storage of these IBCs and also in the transport, because it has to be in certain temperature conditions? So you didn't talk about that, but there is a storage issue at the level of feed mills as well.
Yeah, you're right. We didn't address. You mentioned a little bit about cold or hot and so on, but it's important.
I want to point out that it's true that there is a tender today that some liquids, when you transport IBCs, you are transporting certain amount of a carrier, water or other liquid. So there is a tendency from the additives manufacturers to do more concentrated liquids, okay? And then it's necessary to develop also some kind of on-site equipment to dilute this to the correct. But this is very much reasonable than to transport water. Okay.
So there are different aspects on the questions. First, I would say the IBC, the recycling, the elimination, and so on. So maybe you have some comments to put on that, Mark.
This is a good question, but in this case, I think we must differentiate the types of additives. So basically, I will take two opposite cases. You are true in some cases. Let's come back to the liquid enzymes, which are most of the case sensitive to temperature, let's say to high temperature. For instance, for our enzymes, we generally advise to store them below 20 degrees. So in some hot countries, definitely we do transport them in refrigerated containers. And we also advise to store them in cool rooms, such like powder vitamins or even powder enzymes, to be below 20 degrees. So this is for the, let's say, sensitive additives. On the other hand, if we come back to the liquid methionine, which is not sensitive at all, it has a very long shelf life. Actually, they can be stored outside, and this saves some space in the feed mill, which is not negligible.
Yeah, so it's quite interesting, and but Joanne already jumped onto the next phase about the future, because when we talk about concentrated products, talking about the liquid, because the first thing is the cost of transport. You need to concentrate the product to reduce at the maximum the cost of transport. But in that case, you are asking the end user to do part of the job, to dilute the product. But maybe done on site, it's also very efficient.
I think this will be one of the next developments, and I am pretty sure that most of the additives manufacturers are working on this, because it does not have sense to transport carriers. Okay, they are working in more concentrated products, or even products that could be easily finalize the process on site. Okay.
How do you see, all of you, how this is the evolution of the liquid product addition to the feed mill? Do you see that it's growing? That I remember, just as an anecdote, when I started in the company, we sold raw bio at that time mainly on liquids. We had 95% liquids, and then after there was a demand to have more powder and so on. And now we see people very interested by the liquid application, the efficiency of the liquid application. So obviously there is a demand. Do you think that today there is an evolution towards the liquid, or we will have always roughly the same level of usage of liquids?
Yeah, I think that we're in a phase at the moment of trying to handle more of these materials directly in the mill, whether it be micro ingredients down to very low inclusion rates through a dry carousel, or also using concentrated liquids. I think that's inevitable to try and control our costs, you know, to the maximum, and to try and keep an edge. So it's a continual process. There is an appetite to spend and invest now, particularly in an era of high feed costs. It makes much more sense to utilize these products and to utilize them as efficiently as possible. So I think it will continue.
Mark, you want to add something?
Actually, I fully agree with Tom. We are all industry people, so we are pragmatic. We are not dogmatic. So I would mention two conditions for the growth and this trend of liquid usage in the feed mills. First of all, is the interest for the feed miller and the animal production sector. If there is no interest, no way. That's the first condition. The second condition I would put as an Adisseo person is the interest for the additive producer. It may give us a better access to the market, and also it may improve our cost efficiency. But again, totally depends on the process of production of the additives. If we come back to the liquid enzymes, it's a fermentation process which is liquid. When you go to powder, you need to formulate, meaning to give the good galenic to the product to be used. So you need to dry it, you have some losses, it is more costly than making liquid. But then Johan is right when saying transporting more water than enzymes is questionable. So definitely we work on that. I will finish with two examples. About liquids. We recently launched a new product called RevoBio Phi Plus, which is a phytase, single phytase. We mainly promote it in liquid form. We kept the powder form, but our main focus is on the liquid. The second one, again, coming back to our core product, which is liquid methionine. When I joined Adisseo a few years ago, there were 2 suppliers of liquid methionine. Today there are 4 or 5 suppliers. It translates the interest of the market for that. So I would conclude on this is the right combination between formulation, I mean galenic of the product, and its application. And the answer is there. Is it in this combination?
You often challenge, Johan, by the supplier, the designer of products, about new liquid application. Do they are contacting you in the process of developing a product?
Yes.
Yes.
Yes. Yes. Right. As you mean for the new developments,
yes,
right? For
yes.
more, yes. Because sometimes it's necessary to develop new on-site equipment. For instance, for diluting online, okay, to get the right concentration. If you ship more concentrated product, this does not mean that you will use it that way. You need to dilute it before before using.
I would say in the liquid we do that, but in powder we do that for many years with the premix and so on. It was a basics concentrated product that you have to dilute before to incorporate in the feeds.
But the challenges are the same at the end of the day. If you want to put 10 grams per ton of powder, the challenge is the same. To put 10 grams of liquid is the same challenge. Not the same solution, but the same challenge.
So for all of you, there is no further question about the concentration, homogeneity, application of liquid compared to powder. It's just a question of accuracy, control, analysis, and so on. There is no...
You have the same objective, but the solutions will be different.
Thank you. We have one more question.
Yes, Pierre-André, I'm with John.
I'm just wondering if the addition of liquids at the mixer has any effect on optimum mixing time, and is there an optimum speed of addition of the liquids and an optimum time for the mix? Is it different between an all dry and when you have liquids added?
Yeah, we talk about the quantity of water, but we don't talk about the physical characteristic and the change when you put a bit more liquid in the mixer. What would that affect in the mixing time, in the operational time, and after, obviously, the pelleting process and so on? Do you evaluate that also?
Well, it's not something that we've had to deal with to date because the levels of total liquids going into the mixer are very manageable. There is no big issue. But I have asked the question before. I think unless we tested individual feed mills, we may not get the exact answer. But we always have the flexibility of adding more of the oils, as Mark mentioned, not in the mixer but add in the sprayer. So it gives us a little bit, maybe another 1 or 2% possibilities in the mixer anyway.
So today there is no constraints to say, okay, we are just at the limit. We still can put some liquid in the mixer or after.
I believe so, yes.
Okay. Yeah.
Okay, just I think we must go on. I would say the main message I want to pass today to reply to your question, John, is that adding micro liquids in the mixer does not impact on the total mixing time. I would never recommend a customer to increase in his mixing time, especially if it's a bottleneck, if it's in his factory. So definitely, dealing with Adisseo's engineer, a feed miller will never increase his total mixing time.
Thank you. And just to conclude, what do you want to add more on this topic of including liquid in the feed mill? How do you see the future, and with your recommendations? What I understood that there is no limit, practical limits today, but how do you see the future, or how can you challenge each other to say, okay, I would love to see the evolution in that direction?
I think my flight is leaving. No, the main big thing for us is we need to have access to the production base for both liquid and dry. We need to be able to handle strategically both, and we need to understand how to use them effectively and efficiently. After that, we don't have a preference for one or the other particularly, but we need to be able to use them when the time arises.
You mentioned, Mark, about the Rabbi of 5+, but as a supplier today, you are pushing more on liquid or pushing more on powder?
Again, totally depends on the type of product, and it totally depends on the context. But to reply your question, Pierre-André, I think that today, especially for some products, I think about enzymes mainly, we should go, as mentioned also by Johan, we should go to more concentrated product. But more concentrated products means the proper solution to apply them. Today, for instance, enzymes are applied at 100 milliliter per ton minimum. Maybe tomorrow we will go below this level. So that's a challenge. I would add something else. We may also add tomorrow some powder, some additives in powder, but using liquids as carrier. So again, we must develop with people like Mangra, with partners like Mangra, some new solutions to apply additives differently. And we already started to work on that.
So there will be evolution in the future on the way we will use micro ingredients, additives, and so on.
That will be another solution.
Yeah. Any point to add, Johan?
No, just to mention that I forget to mention before. I think it was one Rob's question. It's very typical that the customer used to ask, especially for the adding fat and oils into the post-pelleting, it's a very typical question to ask the supplier, the equipment supplier, how much fat and oil they can add. As Mark said, it depends strongly with the material they are using, but not only the material. So it's not the same if you have more and less corn, wheat, barley. The absorption is different, but also the pelleting process affects the absorption capacity. Okay, and I was just thinking, for instance, in the pet foods. Pet foods is extruded product. In the post-pelleting, they can add over 12, 15, 18% of oil. Something that you cannot do it with a pellet. Okay, so absorption.
Definitely we need to work all together to refine the solution and develop the most simple solutions to apply on the field. So I would like to thank all of you for this interesting debate, and to our audience too. And I just remind you that there will be more events this afternoon at 3 p.m. We start an event on oxidative metabolism, and just after an event on selenium. So it would be quite interesting to talk with professors and so on about this issue about oxidative metabolism. And we'll continue during the week. Tomorrow we will have the Nestor Day, the Net Energy Day. So I think we'll have a lot of exchange and even practical workshops. So thank you very much, and see you again in the afternoon.